multiply and express as a simplified rational. State the domain. So we'll start with the domain. The only numbers that will make this expression undefined are the ones that would make the denominator equal to 0. And those are the situation, or that situation would occur when either a, b, x, or y is equal to 0. If any of those are equal to 0, then we have an undefined expression. So we could say that the domain is all real a's, b's, x, and y's except 0. Or we could be specific, except a, b, x, and y can't equal to 0. Or you could write maybe write this. Given that a, b, x, and y does not equal 0, that none of them can be equal to 0. These are just multiple ways of stating the same thing. Now, with that stated, let's actually multiply and simplify this rational expression. So what we have is, so when we multiply, you just multiply the numerators, multiply the denominator. So you have 3x squared y times 14 times 14a squared b in the numerator. And then in the denominator, we have 2ab times 18xy squared. And let's see where we can simplify this thing. Well, we can divide the 14 by 2 and the 2 by 2 and see what we get. 14 divided by 2 is 7. 2 divided by 2 is 1. And then we could divide the 3 by 3 and get 1, and divide the 18 by 3 and get 6. Every time we divided the numerator and the denominator by 2. Now the numerator and the denominator by 3. So we're not changing the expression. And then we can divide a squared divided by a. So you're just left with an a in the numerator, and a divided by a is just 1. You have a b over a b. Those guys cancel each other out. You have an x squared divided by an x. So x squared divided by x is x, and x divided by x is just a 1. So it just becomes an x over 1, or just an x. And finally, you have a y over a y squared. So if you divide the numerator by y, you get 1. You divide the denominator by y, you just get a y. So what are we left with? We are left with, in the numerator, all we have, these 1's we can ignore. That doesn't really change the number. We have a 7 times a times x. That's what we have in the numerator. And in the denominator, we just have a 6y. 6y. And we have to add the constraint that a, b, x, and y cannot equal 0. Because when you just look at this expression right here, you're like, hey, what's wrong with x? Or, I mean, there isn't even any b here, so it's a little bit of a bizarre statement. But you say, hey, why can't x or a be equal to 0 over here? It doesn't make it undefined. But in order for these to really be the same expressions, they have to have the same domains. Or actually, if these were functions that equal them, in order for that f of x to be equal to this f of x right over here, you'd have to constrain the domain in a similar way. So it's not like this is fundamentally a different expression if you allow x's and a's. In this one, you can't allow x's and a's. For them to be really the same, you have to put the same constraints on it.